Today I'm going to show you how you are going to use micropipettes to measure small amounts in the measurement of microliters of DNA and other reagents or chemicals to do our biotechnology labs. We are going to be using what are called the mLINE pipettes. So in this picture, you'll see kind of a typical lab setup of some of the tools, most of the tools that you will be using. So on the rack, you'll see three different pipettes, and you'll notice that they have a different color up at the top. And this one is a gray one that measures 0.5 to 10 microliters. This one has a yellow tip, which measures 10 to 100 microliters. And the one with blue on top has is able to measure 100 to 1,000 microliters. Now, you'll see some other tools on the rack as well. There's three different boxes. One has a gray lid, one has a yellow lid, and one has a blue lid. Then you'll see something called a rack, and the rack is what holds your reaction tubes, and there's different size reaction tubes. And then you will see a little plastic beaker, which is what we use for our waste containers. And we're going to go through how to set and read the pipettes as well as how to actually pipette. First, there are 4 rules for safe pipetting. When you're pipetting, you always want to make sure that you are holding the pipette upright, because if you have it on its side, any liquid that might be in the tip is going to get inside of the pipette, and it's going to mean that the measurements are not accurate. So you must always hold the pipette in an upright position. Now, you also never want a pipette without a tip on. Right now, there is no tip. The colored boxes that I showed you, those hold your tips, and you always need to pipette with the tip on. Now, if the pipette has a yellow dial up at the top, you are going to use the tips that have the yellow kind of cover once you open it up. Okay, and so you're going to get a tip on your pipette and make sure that you're holding your pipette upright. Now, you never want to use the same tip twice, because you can contaminate your different samples if you're using the same tip for every step in the lab. So every time you pipette, you need to use a new tip. Now, when you are pipetting, you need to have the right amounts. And so this window tells you how much you're going to be pipetting. If you need to change that, you have to press and hold this little gray button on your pipette, and then you can turn this dial and you'll notice that my numbers are changing. If you don't press that button, you're going to hear this really loud sound that you never want to hear. It's going to be a really, you can hear each click. It's super, super loud. If you hear that, you are doing it wrong. Always press and hold the little lock as you are changing your numbers. Okay, and then the last one is always keep your eyes on the tip. So as you're pipetting and picking up liquid, you don't want to have it down here because you can't see what you're doing. You want to make sure that you're actually sucking up liquid. So you always need to hold it at eye level so you can see what is happening. So we're going to look at how to set and read the micropipettes. Now, there are 3 different ones. If you look at this picture here, you'll see one has a gray top, one has a yellow top, and one has a blue top. Now, they come in 3 different sizes. So the smaller one is what we call an M10, and it measures the smallest amount from 0.5 to 10 microliters. And it's hard to see on this picture, but right down here underneath the number, you can read that it says 1,000. But right underneath the number, there are, it's written on the pipette, the range that it measures. The medium one has the yellow on the top, and that measures 10 to 100 microliters. And the larger one with blue up at the top measures from 100 to 1,000 microliters. And it's called the M1000. This one's the M100, and this one's the M10. Now, if you look at the pipette right here, okay, in these pictures, you are kind of looking at it on its side. When you are looking at this, you're going to see here the number 100, here's the little lock button, here are the windows, and here's the range number underneath. And so you'll see each one, the 10, the 100, and the 1000 are a little bit different in their range numbers. Now, when you are wanting to pipette, the first thing you need to do is you need to figure out which pipette you're going to use. So for example, if I give you instructions to measure out 9.5 microliters, which pipette would you use? Okay, so if you look at the bottom part, which you can't really read on this screen, but if you look up here, we have 0.5 to 10, 10 to 100, 100 to 1000. If you want to measure 9.5, you are going to want to use the M10, which measures from 0.5 to 10 microliters. Now, the next step, after you've figured out which pipette you want to use, the next step that you are going to do is pay attention to where the decimal point is. Now, there is a decimal point on the M10, kind of right in the middle. So if we want this one is set to 4 here. It's 4.00. So if we want to put 9.5, the first one we're actually going to leave blank. You'll notice that there's no like 0 at the beginning, but you'll leave that blank. But technically there'd be like, that's the 0 in that placeholder there. And then you would do 9.5, and then there would be an extra 0 at the end. So if you are setting this up, you would put 9.50. Now, if you had the instructions to measure 95 microliters, so 95 microliters, you'd use the M100, which measures from 10 to 100 microliters. And so you want to first figure out like where's the decimal point. And in this case, on the yellow pipette, the M100, you will see a decimal point over here on the right before the last box, like we call these little windows that you're looking into. So you would write for 95, it would be 95.0. And then if we wanted to measure 950 microliters, first figure out what pipette to use. 950 fits within this range, 100 to 1000. So we'd use the M1000 pipette. And when looking at this, there are no decimal points. So when we're wanting to use this, we just need to type in what that number looks like. So 950 would be kind of like 0 and then 950 at the end. The decimal point technically is like over here on the right-hand side. Now, you always want to unlock your micropipette to dial the amount. And again, that's pressing on this button. And then you can twist this so that it gets to the number that you want it to go to. So you're going to do some practice. So you have a micropipetting practice worksheet, and the steps that you're going to take are up at the top. So step number 1 says record the pipette you would use. So if we're looking at this first one, it's 13 microliters. Which pipette would you use? You want to go back and look at the how to set and read micropipettes. You'll have this in your packet. And what you're going to do is first write down in this box right here which pipette you would use. If you wanted to measure 13 microliters, you would use the P100. So you're going to put 100 in that box. Then you're going to color in the dial or plunger with that correct color. And so the M100 has a yellow little dial, which is kind of on the plunger type part. And then you're going to draw in where the decimal point is, if there is a decimal point. So in this case, it is after the third box. Then you are going to fill in what the windows would read. So 13 would be 13.0. So you'll go ahead and follow these steps for the rest of the problems. So now we're going to go through the process of how to pipette. And the first thing we want to do is this first column. We want to prepare the pipette. And so let's say that we had to measure 90 microliters. We want to first choose the correct pipette. So you can look at the name of the pipette or the range of the pipette, which is written on the bottom of this window area. And for 90 microliters, we want to use the M100, which measures 10 to 100 microliters. Then we need to unlock and dial the pipette and then lock it again. So basically, to unlock, we just press down on the lock button, and then we're going to turn these so that it goes to 90. So I can't see what I'm doing right now, so I'm just going slowly and I'm turning it while my finger is on the button to unlock it. And I'm just going to keep going until I get to 90.0. Okay, now the next step is to put a tip on it. And remember, there are 3 tip boxes. One has yellow, one is gray, and one is blue. Since we are using the yellow pipette, we are going to use the yellow tip box. And when you use this tip box, it's going to be sitting on your desk. You're not going to be holding it in your hand. And when you open it, I don't want you to keep the lid open like this, because as I'm breathing on this and that stuff in the air, it's going to get contaminated with things that we don't want in these tips. So when you open this and when you're putting a tip on, you want to open it like it's Pac-Man, like when Pac-Man's going and eating all the little dots. So you're going to open it just enough that you can get your pipette into it, and you're going to push down with your pipette, not super hard, we don't want to break the pipette, but hard enough that it sits on the pipette, and you'll close your box. Again, it will be sitting on your desk the whole time, you're not actually holding the box. Now that I have my tip on it, I need to hold it upright, because when I see a tip on here, I don't know if there's liquid or not on it as I'm walking around the classroom. If there happened to be any liquid in here, you've picked up some DNA or picked up some calcium chloride or other materials that we're using, if you have it on its side, or even upside down, what might happen is any liquid will get into the barrel and it will mess this up. So you always need to hold it upright. And you'll notice that there's this little hook right here that kind of fits right on your hand. And then you can just wrap your fingers around it and your thumb could go on the top. But I'm not pushing down yet. When you push down on this, you want to control the speed with your thumb. You don't want to click on it and let go like this, because that can damage the mechanism inside. So you're going to control the speed. You're going to go slow as you're pushing down and as you're releasing. We're not pushing down or releasing yet. That will be in the next set of steps. But also when you're pipetting, you want to hold it at eye level so that you can see what it is you're doing. All right, so the next set that we're going to do is we are going to suck up liquid. And you're going to notice that there are what are called stops. There's 2 stops. If I press down on this pipette on the plunger part up top, I'm just going to press gently until it kind of stops. And then I'm going to put it into my reaction tube that has liquid in it. I'm pretending there's liquid in here, but I'm going to put it so it's just under the surface of the liquid. And then I'm going to release the plunger slowly. And then I'm going to withdraw the tip out of the reaction tube, but I'm going to kind of drag it along the side, because sometimes you might get a little bubble of liquid and it's on the outside of the tip, and I don't want to take that with me. So I'm going to just kind of drag it along the inside part of the reaction tube, so the drop stays inside of the reaction tube. Then you're going to spit out the liquid. So I have another reaction tube. This is a smaller one. And I am going to want to put my liquid into here. So I'm going to, again, hold it at eye level. And I'm going to touch the tip so that the tip is touching the inside of the reaction tube. This time when I press, I'm going to press slowly down and it's going to stop, but then I'm going to press even more and it's going to go to what's called the second stop. And I'm going to keep my finger on it at the second stop, and then I'm going to slowly drag my tip out. And so my finger is still pressed down to the second stop here. Once my tip is out, my pipette is out, I'm going to slowly release so there's no clicking noise. And then, since we can't use the same tip twice, we're going to put the tip in the waste container. How to do that? Right here on the pipette, on the front side, there's this little mini plunger, and that's going to eject the tip. That's going to dispose the tip, and we're going to put it into our waste container. So we're going to be practicing all of this in class, so you'll be a pro at how to use a pipette. One of the things that we might also be using in class, especially for the first few labs, is something called a centrifuge. If we have little tiny amounts, like you're going to have little dots of liquid, microliters are super small, they might all stick to the insides of the tube, and we want to make them all go down to the very, very bottom. And so what you'll have to do is make sure your reaction tube is closed, okay? And when you put them into the centrifuge, it's going to spin them around super fast, kind of like a washing machine. And what it does is, as it spins super fast, it's going to basically pool all that liquid into the bottom of the centrifuge. So all those little drops will be combined together at the bottom. But just like a washing machine, if you've ever put in, if your washing machine starts kind of jumping around, if things aren't balanced, it's going to be a problem. Like if you have lots of heavy shoes on one side and like nothing on the other side of the wash, it's not going to be happy. So you want to make sure like all the clothes are spread out or whatever's in your washing machine. So we want to do the same thing with our centrifuge. So we want to keep it balanced. So I'm going to show you how to do that. Also, you'll notice it has a lid right here. So when you close this lid, it starts spinning. You don't want to open it up and reach in right away because your hair might get stuck in it, your fingernail might be ripped off. So you want to make sure you just open it a teeny bit, and I'll show you this in class, but it will start slowing down and it will completely stop. Once it's completely stopped spinning, you can open the lid all the way. On this centrifuge, there's no dials, there's no knobs to turn on. It just automatically turns on when you close the lid. But we might be using a centrifuge that has an on-off switch, and the only dial that you would then turn is the knob for the time, for how long you want it to spin. So if you look at this centrifuge, you'll see there are 6 holes, and so that's kind of what this is representing here. So we're going to look at how to keep our centrifuge balanced. And so you'll be putting reaction tubes into the centrifuge. And when there are 6 holes, if you have all 6 of these, you want to make sure they have the same amount of liquid, the same amounts. If I had this one full and one small, it's not going to be balanced. They need to be the same amount. But it's pretty easy to balance this one as long as they're all the same amount. You're just going to fill up each of the holes if you had 6 tubes. Now, if you had a tube that, like 2 tubes that had half the amount of liquid in, and then 4 tubes that had full amounts, these could be the 4 tubes that are full amounts, and these 2 here could be like the half amounts. You want to make sure that you're always balancing the opposite direction. Okay, so like if this one's small, but these 2 are full, it will still be balanced. Okay, if we have 5, can you find a way to balance the centrifuge? Okay, so kind of one of the main guidelines is as long as they are directly across from each other, it will be balanced. So with 5, you can't really do it. Like if I fill out these 5, this would be unbalanced with this one empty because it's across from here. These 2 balance each other, these 2 balance each other. This one, it's not balanced. It's going to be a problem. So for 5, you have some different options. You could borrow a tube from another group, or you can do 4 at a time. So just have these 4 together and spin it, and then take 1 tube out and replace it with your 5th. And so you just are spinning 4 again. So 5 could be a little tricky because this extra one is going to be empty, or that could be, again, a tube you borrow from someone else. So for 4, as long as they are across from each other, this is balanced. So those 2 would be balanced. If you had these 2 across from each other, it's balanced. It's okay that these are empty because the opposite sides are full. If you had 3, you can't really do across from each other But to balance this, you could have them in the shape of a triangle, and that would be considered balanced. If you have two, remember it just needs to be across from each other. And if you have one, you kind of have a problem because you can't just have one in there. It's not going to be balanced with something directly in front of it. So you can borrow one from another team, or you can fill up another tube with water with the same amount of liquid to balance it. So we want to make sure the centrifuge is always balanced, or it could damage the centrifuge. Now, one of the other things that we're going to need to do is learn how to convert microliters to milliliters and back and forth. And so we're going to use something called the BS conversions. And what BS means is B is for bigger and S is for smaller. And milliliters is a larger unit than microliters. You're probably used to measuring milliliters. You see it on a ruler. That is a larger unit than microliters. Okay, we are measuring micro teeny amounts. We're measuring DNA, which is teeny tiny. So that's the smaller unit. Okay, so milliliters is bigger, microliters is smaller. Now, when you are doing the conversion, it's 3 times. There's a 3 times difference. So you're going to move the decimal 3 times, either left or right, depending on which way you're converting. And so when you're going from milliliters over here to microliters over here, you're going in this direction. You're going towards the right. And so you're going to move your decimal point 3 times to the right. If you're going from microliters to milliliters, you're going from small to big, and you're going to move your decimal point 3 times to the left. So we're going to look at some practice problems, some examples. Okay, here we have 425 microliters, which is the smaller one, and we're going to move to milliliters, the bigger one. Now, I don't see a decimal here. You might need to add in your decimals. So 425 is really the same thing as 425.0. And if we're going from microliters smaller to milliliters bigger, we're moving our decimal point 3 times to the left. So I'm going to go 1, 2, 3. So our answer is going to be 0.425. Let's look at another example. If we have 0.5 milliliters and we want to go to microliters. So this time we're starting with the bigger number and we're ending with the smaller number. So we're going to move our decimal 3 times to the right. We have a decimal already here, so we're going to go 1, 2, 3. So I'm going to need to add in some zeros, okay? So 0.5 milliliters, I'm moving it over 3 times to the right. So it was here, it was right here before the 5. 1, 2, 3. So it's going to be 500 microliters. And you'll be practicing some of this before you're actually having to calculate things on your own.